Excellent. Good afternoon, everyone. Thank you so much for joining us for this workshop. Very important information. And we are so happy to be here with our speaker, Mr. Rob Benetton. Rob Benetton is University of California Cooperative Extension Bay Area Urban Agriculture Advisor, supporting small-scale food growers, extending knowledge on urban soil quality, resource management, and urban agriculture policy. Rob teaches on urban soil management and heavy metals exposure prevention, is working with local groups on mapping urban food growing sites in the East San Francisco Bay Area, and specializes in providing technical assistance on urban ag community garden site governance. Welcome, Rob. Thank you so much for joining us and talking to our community today. The floor is yours.
Thank you. Thank you. Good afternoon, everybody. I hope everybody's doing okay today. Thankful that today is a sunny day. Going to go ahead and dive into sharing screen. Give me a hot second to pull up the shared screen here. And slideshow in motion. Hopefully it goes. There we go. All right. It's thinking. Computer's thinking. There we go. All right. Cool. All right, everyone. Good afternoon again. This is Improving Your Soil Quality for the Urban Food Grower. And thank you so much for the introduction, April and Sony. It's great to have everyone here and to collaborate with the Healthy Homes Department of the Community Development Agency of Alameda County. That's what the ACHHD is, if you didn't know. So I'm going to just dive right in here. You know, soils develop over millions of years through a long-term process of weatherization and glaciation. Parts of this country were covered in glaciers over a long period of time, and as those glaciers melted, they carried water and rocks and actually ground against rocks with a lot of pressure over time. And in California, not a huge part of the state was, you know, under ice, just most parts of the Central Valley, as you can see here. But as that process would occur, rivers and low-lying areas would overflow over time onto the banks. And so there would be silt depositions onto those banks a little bit at a time over a long period of time, over millions of years. Also, as trees and plants and other materials, other plant living organisms ultimately drop their biomatter, right? They would also deposit organic material over time. So the basic concept here is that soils derive from parent materials, right? There are three main kind of parent materials in geology, the study of rocks, right? They're igneous, metamorphic, and sedimentary. And in most cases, sedimentary was under major waterways and oceans over millions of years. Igneous was formed from molten lava from volcanic eruptions, and then cooled and dried lava over time. And then metamorphic rock was largely the placement of large amounts of pressure onto rock particles. I don't know if anybody on the call is old enough to remember Christopher Reeves in Superman, when he takes a piece of coal and squeezes it really, really tightly with a lot of pressure, and it turns into something. Does anybody remember what it turns into? Ooh, it turns into a little, to a diamond. And so that's an example of metamorphosis of rock formations, right? So there are three main kinds of parent materials, and this is also based on temperature and pressure and weather combined over millions of years. And as soils form horizontally, we get what are called soil horizons. So can everybody say horizons? Horizons, all right. So these horizons are largely bedrock at the bottom, and then parent materials, and then subsoils right here, the 12 to 36 or 12 to 48 inches, and then the topsoils. And in urban areas, and those topsoils are called the A horizon, right? They're usually 6 to 12, 6 to 18 inches. In urban areas where there's been a lot of development, where houses and residential spaces, commercial malls, etc., have been built, in many cases, the topsoil was removed to put in the building. And in the process of that, the topsoil sometimes was put back, sometimes it was moved off site. But essentially, this top layer had the most living matter in it, the most organic matter. Everybody can, if you'd like, repeat after me. We sometimes say organic matter is.
Organic matter is
Something that is or was
something that is or was
once alive.
once alive.
Once
Once
alive.
alive.
Alive. Right. So we're going to say it all in sequence now. Ready? 1, 2, 3. Organic matter
is
something that is or
something that
was
that is or was once
alive.
alive.
Right? Exactly.
Okay.
So we want to work with soils that have a lot of organic material, because organic matter can help hold nutrients and water for our plants, right? If we have healthy soils, we get bountiful blossoms and healthy harvests, right? And so how well a soil holds together is something called aggregate stability. Can everybody say the word aggregation?
Aggregation.
Aggregation. Okay. So aggregation is basically how well a soil holds together when it's wet and how well a soil holds together when it's dry. And aggregate stability is based on particle size of soils, pore space in between soil particles, and organic matter. So this is your goal. Your goal is a dark, rich, crumbly soil that holds water well when it's wet and lets water go over time as it dries out. And that ability to hold nutrients, that ability to hold water is in part a function of how much organic matter is in the soil, and also proportions of clay in the soil too. So what are the 4 things plants need? Can anybody tell me?
Sun is one of them.
Okay.
Okay, water, sun,
Okay.
organic matter.
Okay, getting there, right? So
Okay.
the organic matter, which also has nutrients, right? And then air. Does anybody know what parts of the plants need the air that we might not think about?
Roots.
The roots. Very, very good. So water, sunlight for photosynthesis, right? For the ability for plants to grow. And then air right around the roots in particular, and nutrients, right? When we talk about nutrients, we're often talking about macronutrients and micronutrients. What does that sound like to you in terms of the plant's needs when they need macronutrients versus micronutrients? Do they need a lot or do they need a little? Which do you think is which?
A lot of some and a little of both. Some
There
others.
you go, right? So micronutrients are sometimes called trace elements because they're needed in small amounts by plants. And then macronutrients are those 6 elements that are needed the most by plants. And we are sometimes familiar with micronutrients because we have a lot of both of these kinds of nutrients inside of us. But does anybody know what hemoglobin in our blood is made from? What's in the middle of it? Anybody know? Little trick question, right? It's a micronutrient. It's iron, right? And you know how sometimes when folks are cold, sometimes they need a little iron in their blood. Maybe eating some red beans might help, right? Kidney beans. And then macronutrients in leaves, right? The process of photosynthesis occurs because of magnesium being at the heart of chlorophyll. So macro and micronutrients really indicates the extent to which plants need particular nutrients and how frequently, how often, and what levels of concentration. The macronutrients are nitrogen, phosphorus, and potassium, and then calcium, magnesium, and sulfur. Now, if you ever buy fertilizer in a store, they'll tell you 3 numbers on the package in the front. It's usually NPK, right? But are they telling you the whole story? They're not telling you the whole story, right? Because the reality is plants need decent amounts of the other three macronutrients, the calcium, magnesium, and sulfur too. And they also need small amounts of the micronutrients, nutrients like iron, nutrients like boron. Can anybody say the word molybdenum?
Nope.
Molybdenum is one of those micronutrients, right? That you will almost never hear about being deficient in plants, but sometimes you'll hear about them in being deficient in soils in greenhouse growing systems. But it's one of those micronutrients that plants need a little bit of, right? So chemical nutrients plants needs, right? We talked about macro and micronutrients. We talked about what's the difference in terms of your plant crops needs, right? Macro needing to be more and micro needing to be less. And so we know which they need more of, right? And then in terms of soils, soil is a matrix. It's like a web, right? It's got minerals, it's got organic matter that was or is alive, it's got oxygen, and it's got water, right? Oxygen, the air that we breathe, and it's got water when it rains, and then living organisms, right? So this little slice right here of the pie, right, is the organic matter, roughly 4 to 5%, depending on which soil you're talking about, right? And then the mineral particles, those gritty pieces, right, that are derived from rock formations, are these 45%. And then everybody, please take a deep breath. We're going to take a deep breath. So that air, right, that air that we breathe is about, in soils, is about 25% of the pore space, and the remainder being water when it rains. So when it rains, those pores fill up. You know the pores on your skin, right? Plants have pores too, particularly on the leaves. They're called stomata. Can everybody say stomata? Stomata. And then also soils have pore spaces too. Those are the air spaces that fill up with water when it rains. And so it's through that soil water solution that nutrients can be exchanged and plants can uptake those nutrients in the roots. Now here's another image. It's very, very similar to the pie chart we just saw, but it's meant to be a little bit more three-dimensional, right? So you have to use your imagination a little bit because you got micro colonies of bacteria here, right? You've got some organic matter that is or was once alive, maybe some clay particles, right? And then in this case, we have quartz as an example of some of the soil particles, right? And the water. So this is the complex of soil, right? And so think about it in terms of plants' ability to uptake nutrients, right? Particle size becomes a key part of this conversation. We have, for the purpose of this diagram, I want you to ignore the big gravel piece right here. Just ignore that one for now, right? One day I'll get the time to actually be able to remove that from the image. But in the meanwhile, we're going to talk about sand, silt, and clay. Have you ever gone to the beach when you were a kid and tried to dig a hole in the sand and make your own pool, right? So you could swim in it as a kid, right? And you would run to the beach with the bucket to the water and grab some water, fill up your bucket and run back to your hole and drop it into that hole that you had dug and try to make your own pool, right? Did that water stay in the pool or did it go away quickly, right? Which way did it go?
Down.
Down, right? And
Yeah.
that water went down because there was a lot of airspace in between the sand particles, right? So beaches are mostly made of sand, especially ocean beaches, right? And so sands are generally bigger particles, but they have a lot of pore space, a lot of airspace in between those particles. Silt, as you can see, is much, much smaller. If you've ever walked along like a river or a dry creek where it used to flood when there were heavy rains and really doesn't rain as much these days because of the drought, but at one point, in geological history, it used to flood and that water would overflow over the banks. those fine, soft, smooth silt particles are what would often overflow over the banks of the stream, right, and drop onto those floodplains. So when we talk about places where human civilization developed over time, they were usually around rivers like the Nile and the Euphrates. And so these became very, very fertile parts of the world. They became places where lots of produce, lots of food was grown because there were a lot of nutrients deposited there as well, right? When those riverbanks overflowed. And then clay is the smallest of the three particle sizes, right? You almost can't see clay because it's so small. But the interesting thing is clay, like organic matter, has a lot of surface area. So it's able to hold nutrients and exchange nutrients over time. And like everything else in life, you want a little bit of everything. You want balance. You don't want to do or to have any too much or too little of any one thing. You want to have a little bit of all your needs, right, met. And so having too much sand can allow for some extensive drainage, and it's harder to hold nutrients in that sand. On the other side, clay, because those particles are so small, so tiny, they stick together almost like glue. And so when they're wet, they allow for nutrient exchange, but when they're dry, they can become really, really hard as a rock, right? Have you ever gone hiking and sometimes you step in the mud, right, on the side of the trail? And as the trail dries, when you come back a few days later, go on the same hike, right, you find that footprint is hard as a rock. Similar kind of stuff, right? There's a lot of clay in those soils. Doesn't allow for a lot of air and water flow. So everybody take another deep breath. Okay, that air and water flow becomes really, really important for soil and for plant life in particular, because that air and water flow allows for roots to grow, for plant nutrient uptake, right? So here's the main concept. Soil porosity is the percentage of a soil that is pore space, right? Or it may be filled with air or water. The average soil has a porosity of about 50%, the average soil, right? Sands have larger pores, but less total pore space than clay. So this becomes really important because if your physical structure of your soil isn't so good, everything else becomes problematic, right? So think about air and water flow, okay? Think about different kinds of soils, right? Some soils are single grain and smaller particles, others form bigger clumps and are a little more blocky. Some soils are layered, right, and platy. Others are like a little bit more granular, or maybe more like a prism, right? And then some soils are just kind of like big clumps that hold together very tightly and allow for slow infiltration of water, right? So it's really important that air and water flow through your soils well so you can have healthy produce over time. Again, bountiful blossoms and healthy harvests, right? So how does structure affect water movement in the soil? Well, a good soil structure will have good pore space, plenty of pore space, and that'll allow good air and water flow. A well-developed structure is especially very important in soils with a lot of clay. Lots of the, not all, but lots of the California soils have lots of clay in them. And high clay soils can have poor structure sometimes, and that can restrict air and water flow, right? So good soil structure can help plants stay healthy ultimately and help us to get what we need out of the plants and our ecosystem. So some thoughts, right? Physical indicators of soil quality. As a generalization, the darker the soil, we can say that for the most part, in most cases, the darker the soil, generally the more organic matter the soil has in it, right? The more ability for a soil to exchange nutrients and ultimately support water uptake by plants. And then there's something called soil texture, right? How much the proportion of sand, the amount of sand, silt, and clay we have in the soil is, right? And we can do a few tests to figure that out. And we can do them in our garden or farm space. So it's kind of cool. So I want to encourage you to think about where you are, where you grow your produce, right? Are you growing in a yard space? Are you growing in a housing development or an apartment complex? What are ways you can be a good neighbor, right? One thing is that's possible for you to do is after going through this workshop, you might know a little bit about soils, and you might be able to share some information about soils with your neighbors too, right? The pros and the cons, the things to do, the best practices, and ways to understand your soil better, right? Another one of the tests we can do is the soil suspension and soil sedimentation test. So let's dive into some of these fun tests we can do if we were in person and not on Zoom also, right? But I've got some images to show you how to do them. So what's the definition of soil texture, right? What exactly is soil texture? When we're talking about soil texture, we're talking about, again, how well air and water flows through, but that's based largely on the particle size. The soil texture is very much a measure of particle size of the soil. The percentage of sand, silt, and clay in the soil becomes important in this conversation, right? So sands, silts, and clays have different particle sizes. And so all soils on this planet are made up of percentages of sand, silt, and clay. And like everything in life, like I said, right, having too much sand can be not such a good thing for plant growth, depending on the kind of plant you're growing, right? But especially for our fruit and vegetable crops. Having too much clay can also be a problem too, because it restricts air and water flow, and those particle sizes are so small that's what happens, right? So you want a little bit of each, right? In roughly equal proportions, if you could improve your soil over time to get the best crops, to get nice nutrient uptake into your plants, and ultimately get healthy harvests and bountiful blossoms. And really, the best thing to do also with your crops is really read about them, right? So if you buy plants from a local nursery or a Home Depot or a Lowe's or any nursery or hardware store that sells plants, or if you grow your own, right, from seed or from cuttings or from bare root stock, right, read up about them. What are the needs of your plants, right? Do they need a well-drained soil that might have a little bit more sand in it? Or do they need soil with a lot of organic matter in it? Things to think about, right? Do they need to be watered very frequently or less so? What kind of soil pH do they have? And we'll get into what soil pH is in a hot second. So thinking about soil texture, right? Soil texture is the single most important physical property of the soil. And you can do some basic tests with your hands and your soil, and you can do it with your neighbors, you can do it with your kids, you can do it with your family members. You could also do it as just a therapeutic exercise. If I could afford a home of my own, right, a house, I would actually go out early in the morning and just try to pick up the soil and smell it and touch it and feel it, because it's a very therapeutic thing. It's a sensory process. You can actually learn about your soils by touching your soils, right? Soil texture and doing a couple of these tests we're going to dive into right now will help you understand how air and water flow through the soil, what the potential fertility is, and also what the suitability for building or constructing some kind of a structure on the soil may be, right? So these two tests right here I have with my pointer with the mouse, these are the ball test and the ribbon test, right? And if we were in the Midwest, we would have a pretty long ribbon that would form over time. And again, it's a very therapeutic process. You take some soil in your hand and you wet it down and you feel it over time. You make sure it's thoroughly wet and you try to form a ball with it, like the size of a golf ball or a ping pong ball, right? And that ball is functioning just like what we were talking about earlier in this presentation, like an aggregate, right? We said aggregation, right, is how well a soil holds together well when it's wet, and how well a soil holds together well when it's dry, right? So that's the ball test. That you want to see if you can, over a little bit of time, maybe 5 or 10 minutes, wet down your soil in your hand, a big handful, right? And see if you can form a ball just like that by just kind of massaging it and rubbing it, and over time trying to create a small ball in your hand, in the palm of your hand. And just like that, you can then crush that ball of soil that you created afterwards, if it does form a ball, right, being somewhat wet, and see if you can form what's called a ribbon. That's what this is right here, right? And a ribbon forms over time. Again, it's a very therapeutic and massaging kind of a process. You can close your eyes if you want while you do it, and you can actually feel the soil particles in your hand, right? Does the soil stick to your skin pores, right? Does it stick to your fingers, to your palm, right? Does it begin to hold together and form this ribbon over the outside of your fist, over the front of your fingers, right? The outside of your fingers. So this is another example of a ribbon, right? Again, it's a very therapeutic process. You kind of massage it over time. It might take you 5 or 10 or 15 minutes, right? You want to make sure that soil is thoroughly wet, right? And in this case, this particular soil is quite dark. So we can tell from that, again, that for the most part, most soils that are dark tend to have more organic matter in it, which means that it'll have good nutrient and water holding capacity for your plants to be healthy with, right? And to grow in a healthy way in, right? If you plant the right plant in the right place, following the basic cultural needs of the plant, you'll get a nice healthy plant and ultimately get to harvest what you're trying to harvest from your crops, right? So think of reading about your plant's growth and needs in terms of the plant culture and putting the right plant in the right place. If you put the full sun needing plant in the shade, it might not remain healthy. If you underwater it or overwater it based on your soil type, it may not remain healthy, right? And this test, again, is a ribbon test. If you were in parts of the Central Valley of California or parts of the Midwest, you would be able to form a ribbon that would come over the size of the outside of your fist, and it would hang over your fingers, but not necessarily fall off from your hand, right? That's a function of how well the soil holds together when it's wet, how well it holds together when it's dry, how well it aggregates, right? So we're going to dive in for a hot second and do a quick poll. I'm going to ask if the intro SurveyMonkey questions can be dropped into the chat so we can get folks to answer all of the survey questions. And then we're going to dive into this next piece right now and learn a little bit about soil suspension, which is also called the sedimentation test, soil sedimentation test. So I'm going to ask if folks can drop the SurveyMonkey into the chat. And then in a couple of minutes, if you could also let us know when you're going to drop the first part of the poll in as well. Thank you so much. All right. So we talked a little bit about soil, right? We talked a little bit about soil texture and how soil texture is a part of sand, silt, and clay, right? And how gritty or smooth it might be, right? Think of sand when you get sand stuck between your toes and how it's like a little bit sharp, right? A little bit gritty, right? Whereas if you got clay, more of a clay soil on your fingers or on your toes, right? It's a bit smoother, right? And it kind of sticks to your fingers or your toes more. And also, you know, those particles are so small, you really almost can't see the individual particles as compared to the sand, right? So soil texture, when you're trying to classify soils in terms of texture classification, right? What you do is you take a big handful of soil and you put it into a quart-sized jar, right? Ideally a glass jar, but you might be able to get a quart-sized plastic jar from the 99-cent store. And just a fair warning, you're probably not going to use this jar for too many other things other than using it for soil texture classification for the future. So you can think of it as a one-time investment, but you could use it for testing different kinds of soils in different people's yards among your neighbors and maybe share that cost, you know. Like I said, you might be able to get it from the 99-cent store for like $1 or $2, right? And you take a big handful, like a big handful of soil from your garden space, and you drop it into that bottle, and you fill the rest of it up with water. And you're going to close that bottle nice and tight so that when you shake it, it doesn't like spill all over you and make a mess on your wonderful shirt, right? Hopefully the shirt says the Healthy Homes Department of the Community Development Agency of Alameda County, right? Because that's where you're learning about your soils today. And you're going to close that bottle nice and tight. You're going to shake it for about 2 minutes, right? And you're going to set it down on the table or some kind of flat surface, right? Maybe on your garden boxes, if you've got garden boxes in your yard space or farm space, right? And you're going to let the soil contents settle, right? Again, you filled the bottle by about 1/3 or half the bottle with soil. And then you added water all the way to the very top of the bottle. And then you shook it for about 2 minutes, right? And then you're going to let it settle by sitting it on a flat surface. And we're going to follow the rule of 3s. In the jar, different layers will form because you shook very strongly and roughly, like over 2 minutes, like this, right? And you can have your kids do it, right? They love to do it. Just make sure they hold it with 2 hands and make sure that bottle is extra tight. So again, you don't spill on your shirt, right? And as it settles, you'll have 3 different particle sizes kind of fall out of that agitated water in a particular order, right? And do you remember which of the particles here, the sand, the silt, or the clay was the biggest of the 3 particles? Do any of you remember that? It's the sand, right? So the sand falls out first, right? The sand being the biggest of the particle sizes, right? And then that'll happen in about less than like 30 seconds or a minute, right? And within 2 to 3 minutes, you'll get your next layer, your silt layer, right? And then within about 30 minutes, you'll get a clay layer right here, okay, in that jar. And what happens is over time, you will see these layers kind of form in a nice formation. And if you leave that jar to just sit there, even for like a day or 2, right, you'll get some nicely formed layers. And at the top, there's going to be some light stuff that floats at the very top of that jar. That stuff is that organic matter, right? That's the material that's really light and stays floating for quite a long time. And then you're going to take a ruler and you're going to actually measure the heights of those layers over the total height. And if you registered for this webinar, we're going to send you the instructions for this so you can do it at home and do the calculations at home too, for what's called, again, the soil sedimentation test, or sometimes the soil suspension test, right? And this will give you a sense, when you multiply the fractions by 100, it'll give you a sense of what is the percentage of sand, right? What is the percentage of silt? and what is the percentage of clay in your overall soil, right? And once you've done your measurements of the heights of the jar layers, right, you can actually figure out, do you have a mostly clay soil? Do you have more of a silt loam, right? Or just a loam, which means a mix, right? A mixture. Or do you have a sand layer? That's the majority of sand, right? So again, a loam mostly means like a mixture of roughly equal proportions of sand, clay, and silt, right? So you can take a ruler, and once you've multiplied by 100, you can get your percentages, and you can figure out which of these three you have. This becomes really important for understanding how well air and water flow through the soil, right? That first item we talked about, right? Because if your physical properties of your soil aren't really good, everything else almost doesn't matter, right? These are the first things to improve on over time. And then we talk about chemical indicators of soil, right? What are the macro and micronutrients? We discussed a little bit about how their macronutrients are more needed and the micronutrients are less needed by plants in order to stay healthy, right? And the macronutrients are the nitrogen, phosphorus, and potassium, right? We get a lot of potassium from bananas. Phosphorus tends to be when plants are flowering, right? And that nitrogen is the limiting factor for plant growth. And then micronutrients are more like the molybdenum, the boron, the iron, right? Well, a second set of chemical indicators of soil is the soil pH test. Sometimes when we talk about water, we also talk about pH. Back in like the 80s and 90s, when the commercials on TV would talk about, human deodorant, they would talk about pH, right? So there's various things we talk about when we're talking about pH, but for the purpose of soils, we're talking about pH and pH test results being on a range between 0 and 14. Right. And then we also talk about cation exchange capacity, and we'll get into that in a minute. So again, macro and micronutrients, those nutrients that are needed the most and the least by plants, right? Macro being nitrogen, phosphorus, and potassium, and calcium, magnesium, and sulfur. What part of our human body has a lot of calcium in it? Anybody know? Our bones, right? Exactly, really key. So our bones and our teeth have lots of calcium in them, right? It's really, really important that we have good calcium intake in our bodies, because calcium is also one of the nutrients that makes up our cell walls. Having good amounts of calcium in our body helps us to be defensive in terms of our immune system towards flus and colds and things like COVID, right? COVID-19. So think about that, right? Think about your nutrient levels, right? And also the poll, right? I want you to answer the questions of how to assess your urban farm soil, right? And then strategies to determine if your urban farm soil is contaminated, we're going to get into. Practices to improve soils over time, and strategies to minimize exposure to lead and other heavy metals. So those are the key things I want you to answer right now in your poll as we continue to proceed, right? And then in terms of the plant's needs, right? What are the needs around soil pH? So we're going to get into that, right? Soil pH is a measure of the soil's acidity or alkalinity, right? What are some foods that are more acidic, right? Foods that we might drink maybe every day, right? Like different kinds of citrus juices, like orange juice, right? Or coffee, right? Sometimes some of the sodas can be more alkaline here, right? And why is this important? What does this have to do with plant growth, right? So soil pH is a scale, It's from 0 to 14, right? And how well plants can uptake nutrients in a soil that is wet, right, has a lot to do with the soil pH, right? Anybody here like to eat blueberries, right? I like to eat blueberries in the morning if I can, right? Back when I was eating cereal, I would eat blueberries with my cereal. Now I like to just eat them straight. But blueberries like a pH that's kind of on the low side, right? Like a 5.5 or a 5.7. Goji berries, on the other hand, like a more alkaline soil, more like a 7, right? Now, most plants, their most ideal plant growth is between about a 6 and a 7. So if you get your soil tested for pH, your goal, unless you're growing blueberries or rhododendrons or azaleas, which aren't necessarily edible, but still in the same family as blueberries, right? Your goal is a 6 to a 7. That's the most ideal for plant growth, right? So remember we were talking about our macronutrients and our micronutrients. We were talking about them because what our plants needs were, right? The 6 elements that are our macronutrients, right? Does this sound familiar to you, right? We were talking about calcium being in our bones and potassium being in our bananas that we eat, for example, and then iron being in our blood, and magnesium being in chlorophyll, which is important for photosynthesis and ultimately for life on Earth, right? And then things like manganese and zinc and molybdenum, right? Zinc being really, really important for, again, helping our immune system's defenses, right? Being able to fend off COVID 19 and colds and flus, and ultimately helping us to stay healthy in our local environments, right? And keep our families healthy too, our elders and our children. So this is the pH scale. This image is also a pH scale too, but it focuses very much about macro and micronutrient absorption. So think of this as being a smaller version of the pH scale. Instead of going from 0 all the way to 14, it just goes from 4 to 10, right? And we talked about in the prior slide how between a 6 and a 7 is the most ideal for plant growth. And then ultimately this 6 to 7 here is where most of these nutrients can best be uptaken, right? Notice that most of the bars that you can see of the different nutrients are kind of the fattest, right? The thickest, right? In between the 6 and the 7 range right here, right? Some of them are a little bit more so towards the 7, and some of them are a little bit more so towards the 6 or the 6.5, but most of the nutrients can best be uptaken by our plants when you have a soil pH that is between a 6 and a 7. And if you really wanted to concentrate and center, you could say 6.5 to 7 would be the most ideal. So get your soil tested with a soil pH kit. You can get it tested by going to a local hardware store or nursery and buying a pH kit and getting it tested, unfortunately, depending on the neighborhood in which you live in, right? A soil pH kit might cost you $7, $8, $9 in some areas, or in other areas more expensive, higher real estate areas might be more like $10, $12, $15 for a pH kit, right? Depends on where you are. But if you buy one, right, usually they'll come with a few different potential test sets to use so that you can use them a number of times over years, right? And that way that money can last you a while, right? And then in thinking about our macronutrients, we're also thinking about NPK, but again, are they telling you the whole story, right? They're not telling you the whole story, right? We want to know also what our micronutrients are, what our calcium and sulfur and magnesium are as well. So it's important you not only read the front of the label packages if you're using fertilizers, but read the back too, okay? And cation exchange capacity is the third of the chemical indicators of soil. So I want you to use your imagination. This is a plant, right, growing up, and this is its root sticking into the soil, right? And here is, oops, this is our pre, and you gotta, we pretty soon we want to drop a post at the end of the session, our post assessment. And so nutrient exchange happens right here between the root and the soils. And this is an example of a clay soil, and this is an example of a soil with a lot of humus or organic matter in it. Now remember, humus is not hummus, the wonderful Middle Eastern food we use as a dip, right? That's a different thing altogether. Humus is stabilized organic matter that is no longer gassing off, that is no longer really even compost. It's reached a stabilized temperature, and having amounts of organic matter and some clay in the soil help with the nutrient exchange in the soil. So your plants can uptake those nutrients in water, right? Water is key to plant life and ultimately to the exchange of nutrients over time. So when you get your soil tested, you will get results back for CEC, or cation exchange capacity. And that will be an indicator of the extent to which you've got plant nutrient exchange going on in your soil. So that's what that is, right? So basic concepts here: organic matter and clay have a large surface area. Adding organic matter like compost over time enhances nutrient exchange in the soil. So every time you plant and harvest, right, you should try to add a little bit of organic matter like compost to your soil over time. This will also help later on, as we talk a little bit in a couple of minutes about contaminants too, right? Or even in the next presentation. So adding organic matter will help with nutrient exchange in root zone. It will increase the cation exchange capacity and ultimately help your plants to be healthy over time, right? So what is organic matter? We said it is something that is or was once alive, but I want you to think about organic matter also as being carbon-based, right? The molecular, the microscopic level is basically a backbone, like our vertebra, our column, right? Our backbone, right? Which is made of carbon, and all of the nutrients that plants need kind of come off of that carbon, right? So I like to use the acronym so I can remember what organic matter is of HONK, or honk your horn: hydrogen, oxygen, nitrogen, carbon. But think of carbon as the backbone, right? And then in getting into this stuff, right, we want to understand that by having a healthy soil, we also have healthy plants. And healthy soils include good biolife, right? So adding plenty of compost over time to your soils will help by improving the amount of nutrient exchange, but also the fungal networks there are in the soil that can also help plants to uptake nutrients. By adding compost over time, you can also dilute your soil if there are small amounts of contaminants in the soil, like lead, for example. We're going to get into that. But here, again, your goal, right? Plenty of organic matter in the soil, some living organisms, some fresh residue because of cover cropping, and then decomposed organic matter over time. Your goal: a dark, rich, crumbly soil that holds water well when it's wet and lets it go when it's dry. So think about cation exchange capacity in terms of soil fertility, right? Something that very much affects our water and our nutrient holding capacity. You can see how dark and rich and crumbly that soil is, right? Imagine if you were holding it in your hand, right? And look at the worms there, right? They look pretty happy all around, right? So soil quality in terms of biological life. Worms are really important. Having good, healthy soil that doesn't smell bad, that is dark and rich and full of organic matter, will also have plenty of good bacteria, will be aerobic, it'll breathe well, won't smell bad. You'll know if it's anaerobic, if it smells bad, right? And it might have other organisms like pill bugs and centipedes and millipedes. So don't scare the micro ecosystems, right? Make sure you amend with compost regularly over time to get a good soil that has all of these organisms, right? You're there to support the soil's biodiversity, and diversity in all things is a wonderful thing, right? So here's another example of a healthy soil where root feeding nematode is trapped by a fungus, right? When you have good soil life, some of the good organisms will go after some of the bad organisms that attack your plants, and you can prevent plant diseases this way too, right? So think about cover crops, right? Think about manures in terms of food safety in particular. You want to make sure you have very little to no carnivores in your garden or farm space. You want to watch out for cats and dogs. You want to avoid manures from organisms like cats and dogs that eat meat. You only want to use manures that are fully composted, and it's best to use them in your composting system and not so much in your soil beds unless you have about 100 to 120 days or more of decomposition taking place of your manures in your soils. You want to compost your own food scraps and your own leaves in your yard spaces and make sure it's fully composted before you add in your compost to your soil beds. And you want to ensure that if you're going to fertilize with fertilizers at all, that you're looking out for what kind of solubility you have, right? Is the fertilizer soluble in terms of being a quick release, right? Water soluble fertilizers can sometimes be big money expenditure because they flow into the soil and flow down very, very quickly. Whereas water insoluble fertilizers, or sometimes called slow release fertilizers, will add nutrients a little bit at a time to your soil. And that might be better for your soil over time, right? And then think about embedded energy, right? How many folks do you know that have asthma, right? When synthetic fertilizers are created, a lot of energy is spent making them, and that energy has a fossil fuel footprint, right? Fossil fuels going up in the air create greenhouse gases ultimately, and then lead to asthma as one of the side byproducts of that. So amending with compost and using organic practices can reduce your use of synthetic fertilizers over time and affect the local environment too in a good way. Think about embedded energy in terms of how much energy is spent to make synthetic fertilizers. Think about soil compaction, right? Are you stepping on your soils, right? Are you stepping on the soils where your plant's roots are? How does that affect your plant's water and nutrient uptake? Is water able to infiltrate into the soil, to go downward into the soil so your plants can uptake those nutrients if you're stepping on those plant soils and those plant roots ultimately, right? And then think about the air temperature in the beginning of the spring or the late fall, right? If you're growing in a compacted soil, right, you have the potential for the soil's temperature to warm up even slower in the spring. And so that's something to think about, especially for your summer crops, right, that like warm feet. Think about mulches, right? One of the things about mulches is the ability to hold water, to also reduce upsplash, right, from soil surfaces onto the undersides of your leafy greens, like your spinaches and your kales, right? And that's where, if you've got lead in your soil, if you've got small amounts of contaminants in your soil, you have the potential for small amounts of exposures, right? And we're going to get in way deep into that in soils workshop number 2, right? Safe soils. But think about it in terms of reducing particle upsplash when you're watering. You want to try not to stand there with the hose and do this, right? So that you're minimizing upsplash onto the undersides of your leaves. And you want to mulch with straw in your garden beds, and then wood chips in your pathways, right? You want to make sure you don't step onto your plant's roots and onto the soils where your plant's roots are when you're growing your crops, right? So happy and safe growing, and please stay tuned for the next workshop where we're going to get far more deeper into safe soils, into the sources of soil contaminants, into where they come from, and how to stay safe. But the good news is here, if you mulch your soils, right? If you water with drip and inline irrigation, right? Subsurface irrigation, and not so much with a sprinkler or hose, right? Like that, you're minimizing the amount of upsplash of particles onto the soil. And by managing your soil pH towards a 6 or a 7, right? You're keeping the soil and the plants healthy, and also ensuring that you're minimizing the potential for contaminants at a pH that is more extreme in the more alkaline or basic, more alkaline or acidic levels, right? And then amending with organic matter over long periods of time. Every time you plant and every time you harvest, amend with some compost so that you can ensure that you're improving your soil quality over time, improving the nutrient and water uptake over time. And the thing about amending with compost regularly is if there are low amounts of soil contaminants like lead in the soil, then you can ensure that you're diluting that soil with compost over time too, right? And don't guess. The big thing, if you take nothing else away from this workshop, the big key thing is to don't guess, but to test your soils. Send your soils to a soil lab, and we will provide through email, when we send you the soil sedimentation test list instructions and this PowerPoint, we will also send you a link that will lead you to a list of soil labs in the region that you can send your soils to get your soils tested, both for nutrients and also in many cases for heavy metals like lead, right? And keep in mind that if your home was built before 1978 or 79, that's when you may have some potential for lead in your yard spaces too. And we're going to get into that way deeper in our next workshop. So stay tuned, and we hope to see you participate on October the 27th at either 1:30 or 6:30 p.m. And don't forget to sign up so you get the link in the email. Thanks so much for having me, and we're really grateful for this partnership with the Healthy Homes Department. All the best.
Thank you so much, Rob. You have a question in the Q&A, please, sir.
Okay, cool. Let's see here. If I test the pH level of my soil in one area, can I assume that the pH levels are the same in other areas of my yard, or will it vary? If so, how many areas of my yard do you recommend to test? Well, what you are going to do is this. You actually have the potential to have different pHs in your yard. So you should, at the very least, test between 4 and 6 areas of your yard space, assuming it's an average lot size for a single family home, right? Could be 120 to 180 feet deep by 50 to 100 feet wide, right? So you're going to actually do your soil pH test in 4 to 6 or 4 to 8 spots in your yard. And when we do soils workshop number 2, safe soils, we're going to also talk about how it's important to not only get your soil tested, but make sure you map your soil sample spots so that when you get your test results back, you can actually identify which areas you had nutrient needs in, which areas of pH you had concerns around, and ultimately how to what you would need to do to improve your soil pH over time. And one of the best things you can do is improving your soil with adding compost. So that's the long answer to the short question. And pH can vary in yard spaces. So 4 to 6 or 4 to 8 spots in a yard is the recommended set of areas. And when you get your soils samples sent to a lab, you can actually take from multiple spots and actually combine them and mix them, and then send that sample to the lab. That sample is called a composite sample, and we're going to get into heavy detail on that in the next workshop. So the idea is we're building building blocks, right? We're walking upstairs to understand soils better. And ultimately, this workshop was about the physical, chemical, and biological indicators of soils so that we can do some basic yard tests. And then the next workshop, we're going to dive into the safe soils piece and getting our soils sampled. So thanks so much for the question. And I'm going to also take a look at the chat in case, oh, we got another question. Thank you. Thank you, Hannah, and thank you, David. Can you point to a resource for cleaning up lead, etc., in soils? I can't make next week's webinar. What we will do is we will send lead in Oakland soils article that was done by the EPA in this region, and a couple of other slightly longer articles that have a lot of instructions on both soil sampling and managing urban soils generally in the email follow-up to this workshop. So that will have lots of resources, and I'm available for email too. I can also put my my email in the chat, and I'm wondering if did the chat have any more questions?
Rob,
Tony?
I have a question. I
Okay.
have a question. So Rob, I've heard, it's good to put eggshells in your garden. Is that a not very well managed shortcut to having to using compost, or is there something magical about eggshells?
So eggshells can be good as long as lead wasn't also uptaken by the chickens or the eggs, right? If you're talking about your own yard spaces, and you can add eggshells directly to your soil. You would grind them up, or you can add them to your compost and mix them. Eggshells tend to be a really great source, in particular for calcium, and sometimes they have low amounts of the other macronutrients like magnesium and boron, which is a micronutrient as well. And I hope everybody was able to get that email address I just sent. Oh, there you go. Thanks so much, Joy, I think, for that. And then do we have any other questions? So yes, eggshells are great.
Okay.
Please feel free to add eggshells. Just know that, if you have any kind of a rodent population in your neighborhood already, right?
Yeah.
It may be better to like grind up your eggshells and put them in your compost, because you can build a composting system that has multiple sections or layers or levels, and you can retrofit it well with fine wire mesh to ensure that you don't have any kind of little four-legged critters with long tails like rats or mice that get in there.
We wouldn't want that.
Is they won't be attracted to the eggshells themselves, but they'll be attracted to the wet yolk and the fragrance of the yolk, right? That lovely fine yellow silky liquid that comes from eggs is what could attract rodents. So if you have rodents in your neighborhood, it might be better to grind them up and put them in your compost, but it's a great addition to your compost ultimately, right? And so we do ask you to follow up with doing the some of the best practice assessments, right? We talked a little bit about using soil amendments to improve your soil fertility, mulches, right? And then also farm soil safety in terms of contaminated soils, but we kind of glossed over it, right? So know that we're going to dive really, really deeply into the soil contaminant concern conversation in our next workshop as well. And please do join for that. And that'll be recorded too. So if you register and can't make it, you could probably get the recording. So that's something to think about for David and anybody else who can't make it the next time around. Don't forget to clean and sanitize your surfaces when taking your soil sample tests as well. All right. And then anything else? I think that's about it. We're going to send an email with the recording and with the articles and this PowerPoint to all of those who registered. So don't worry. And then do we have any other questions? No, we don't. All right. How about you, April and Sony and Joy? Any other questions or thoughts, things to
So-
share?
Sony, you had something or no? You get She has a difficult day. No, I think that was fantastic. I learned so much. Thank you so much, Rob, for all of this fantastic information. I can't wait for Souls 2. It's like a cliffhanger. Episode
Right, we
2
kept
coming
it-
soon.
we kept it light so we could dive deeper and get
Yeah.
into that deeper conversation. Because, urban
Yeah.
soils vary a lot. That person
Yeah.
that asked, I think it was Hannah who asked the question about
Mm.
soils,
Yeah.
pHs varying just in a small
Right.
yard space. That's really true, right? In urban areas,
Yeah.
soil vary extensively across surfaces over
Mhm.
large areas, and 1 square foot to the next can be in some ways different over time. So yeah, that's a key question.
Fant-
I look forward
Fantastic.
to seeing you all on the next Zoom.
That
Thank you
sounds-
so much.
That sounds great. Any more questions before we sign off? Anyone? Saying anything here? Okay, this was Joy posting the
Oh, nice.
polls.
We got some nice results there from the polls. Thank you, thank you, thank you.
Very, very good. We'll pull those up. Okay. Well, we look forward to seeing everyone next week for part 2. Stay tuned.
Definitely.
Stay tuned. Thanks, everyone.
Awesome.
Have a great afternoon.
Thanks. Bye-bye.
Bye.